Welcome to Rising Tides of Radical Transparency, why and how to open source your data platform. I really just wanted to pick a title that long to test how long I could actually make it and still have them say, yeah, sure, we'll go with it. But yeah, this talk is a case study of one data engineering project made by a company, us, and it goes through some lessons that we learned in teaching data engineering, open sourcing our data pipelines, and what you can pick up from this code. We'll also talk about how to leverage the lessons we learned to open source your own data pipelines and share this knowledge with your own community. So first, you'll hear me talk about who I am, what I do, and why I care so much about developer education and why open sourcing our data pipelines is a part of that. Then we'll talk through some of the lessons that you can learn from our pipelines that you can apply to your own work. And then at the end, we'll take a few beats and talk about, well, if you're interested in open sourcing something yourself, how to do it, and, well, why you should do it in the first place. But yes, who am I? My name is Tim Castillo. Fun fact, every morning I share a banana with one of my cats. I am a data engineer and developer advocate for Dagster Labs. And being a data engineer and developer advocate means that half of my time is spent building out our data pipelines, and the rest is spent figuring out how to have happy users for our open source framework. I started my career as a software engineer and became a data engineer to chase the hype in the late 2010s, just like everyone else. But on day one of my first data job, I was terrified to see the lack of guardrails and best practices that I had grown accustomed to. And it hurt me to see teams of data analysts and data engineers struggling with problems that I thought had been solved in software engineering for decades at that point. Stuff as simple as version control. And I've since spent the past few years focusing on helping data engineers expand their skill sets in things like the software development lifecycle, testing, and sustainable design patterns. I did this in that first data job that I was talking about earlier, then replicated it in a consulting capacity at some fast-growing startups and some enterprises. And each time, my team members were always frustrated about something. Whether it might be a new tool, new architecture, or new workflow. And each time I noticed that investing time into upskilling the team not only helped solve those frustrations at its core, but also enabled the team to have agency, curiosity, and ownership of their work, which was just super fulfilling. And so now I do this as a developer advocate for an open source Python framework called Dagster. And yeah, this experience of seeing data engineers in pain because they haven't received proper training in writing high quality software is what I see with many people in today's data engineering community. And because of this, I invest a lot of my time in educating folks on software engineering best practices and helping people learn how to be good data engineers. And there are a variety of options available to you to learn how to be a good data engineer, or just how to be a better one. You have your tutorials, your online courses, your books, so on and so forth. And they're all great in their own respects, but they also have their own gaps. As someone who has to write tutorials for work, tutorials are a great way to get started with a specific tool. But their intention isn't to teach you the best practices or deal with complicated scenarios, but rather help you get started with understanding the value of what you're trying to learn. So one of my personal favorite ways to learn and upskill as a software engineer is by looking at other people's code. You hopefully get to see how other people manage different moving parts to make something great. You can observe what decisions people took and the considerations they had, or so you might think. Because finding realistic, good quality projects to learn data engineering from is really hard. And this makes data engineering feel like a really lonely role to be in. A lot of our work has bespoke business logic and nuance that makes it difficult to share what we're working on with other people. Many people have to figure things out on their own, and even once you learn how to do it, once you learn how to do something, it's difficult to share that knowledge with others afterwards. And let me make this statement clear right now. Data engineering is software engineering, but often it doesn't feel that way. When a software engineer wants to learn about writing sustainable code or architecting a web app, they have a plethora of different repositories and examples to look at. For example, if today you wanted to write your own medical record system, there are repositories with custom EHRs that you can look at to learn how to handle PHI and how to securely store it. But if you wanted to learn how to do analytics on realistic patient data, it gets a lot harder to do that. And because many existing references are for source data that doesn't match what real life looks like, such as Kaggle. And generally, it's hard to find good production scale and realistic pipelines to learn from, which is why my team put in the effort to open source our own internal analytics. So Dagster Open Platform is a public repository of Dagster Labs' own data pipelines. It's what we, as a fast-growing SaaS startup, do, and includes part of our cloud product analytics, marketing attribution, and our KPIs. And we do this because we aim to be a resource for data engineers and data teams to help better inspire better practices and better quality data pipelines. It contains our coding conventions, our recommendations, our decisions, and our trade-offs. So you might be asking, well, what can I do with Dagster Open Platform? We'll talk about that in a second. We'll also talk briefly about what Dagster is in the first place. And then we'll go into a little stint about, well, what can you learn about data engineering from Dagster Open Platform? So Dagster is a framework for orchestrating assets in data pipelines. And let me make this clear right now, once again. Dagster Open Platform is written in Dagster, but you don't need to use Dagster to learn from it. And hopefully you'll trust me in that statement by the end of this presentation. But before using DOPE as a way to level up in data engineering, I'm just going to give you enough information about Dagster so you can follow along with these examples. So Dagster is a Python-based framework for data orchestration. If you're familiar with other orchestrators like Airflow, we're part of that next generation of them that solve the pain points in the orchestration space and solve for these pain points from the ground up. This next wave of orchestrators, we've all slowly diverged from each other and specialized in our own ways. In our case, we focused purely on data pipelines and trying to do that really, really, really well. Notably, the assets that are produced from data pipelines. Our users focus on building their data assets, such as tables, files, machine learning models, so on and so forth. And this asset-centric approach comes with features and building blocks that enable people to do stuff like partition their data or rebuild their data automatically if the upstream data that depends on has been updated, and give you some observability over the costs that are involved with it, such as knowing how much it takes to make, or how much Snowflake credits it takes to make that table. So in Dagster, your data pipelines are written and visualized as a sequence of assets. This lets you create an end-to-end data lineage of your entire data platform, from ingestion to modeling to usage. So in Dagster, you say, well, this Stitch sync produces 3 tables, and that this dbt project uses those 3 tables as sources in order to make this dimensional model. And if Stitch has done an ingest more recently than the last time I ran my dbt project, then my dbt models are considered out of date. And because Dagster knows the dependencies and is the one running these assets, you can do stuff like this. So in addition to running things on a cron schedule, your assets can also react to when the data it depends on is updated. In this case, when 7 consecutive days of daily top items is updated, then weekly top items will automatically recognize that it can update itself and start building the partition that needs those 7 days. And then once a few weeks are done, then the respective monthly data also gets updated. If you're not familiar with what partitioning your data is, then no worries, we'll talk about that later. So yes, here is a list of things you can learn from Dagster Open Platform. Here's what we experienced and documented in the real world, not in Hello Worlds. It's not an exhaustive list, but it's also not a short list. And most importantly, once again, none of this is Dagster exclusive. All of these practices and patterns can be applied to any software that you choose to write. Now, to go into detail, we're going to dive into these 4 lessons that were on the previous slide and talk about them in depth. We'll talk about, well, what is this lesson about? Why is it important? How can you do it for yourself and leverage it? And I'll share an anecdote about why we do it personally and how this ended up in our code base in the first place. So the first lesson is to use common design patterns to build more scalable and resilient code. For those of you that aren't familiar, a design pattern is a tried and true tested way of writing code that engineers have repeatedly found and reached for when trying to solve a problem. They are tool-agnostic skills that let you solve common problems that people experience when writing software. You've probably intuitively came up or with your own design, with an existing design pattern that have implemented in your own code, but this is just a framework and mental model on how to approach using them. So, for example, rather than defining a connection to an external service each time it's used, you could reach what's called a singleton pattern to create a single source of truth of how you're connecting or configuring to external services, whether it might be AWS, Snowflake, BigQuery, and such. Or you can optimize and manage how much data you're working with at any given time, such as when you're ingesting from APIs with a design pattern called iterators. So here's an example of how we use a factory design pattern to programmatically make many pieces of our data pipeline at once. So we use Stripe to manage the billing of our cloud product. And Stripe has a native integration of Snowflake to sync all changes in Stripe into Snowflake tables in close to real time, courtesy of something called Snowpipe. This meant that Dagster wasn't managing the construction of this asset, but we still wanted to document and be alerted if they weren't updated recently. So we use a factory pattern to programmatically make a new Dagster asset for each of these tables. In this factory, we create a standard definition and a standard test for how up-to-date the data is. And because it's all sourced from that list of table names, this means that anyone, such as our finance team, can have the agency to freely add new tables that they want to monitor, and those new tables will have the same level of data quality, testing, observability, documentation, as the rest of the other assets or tables that are made from this. And that as we as a data team make new changes, such as hypothetically introducing an anomaly detection model, we as data engineers can rapidly apply it to all these tables at once. And this creates a scalable data platform where many people can contribute and iterate while still meeting the bar for quality that we as a data team want to set for our data pipelines. So yes, use design patterns to help you write sustainable and scalable code. The next bit is to invest in your developer experience. Spend some time every now and then cleaning up your code base and making utilities that make your team more productive and efficient. Because happy developers who have less to juggle or manage to get things going are substantially more productive. And something you can do to enable this is standardizing developer environments and abstracting away parts that not every developer needs. In our case, the example that I wanted to highlight was our makefile. As simple as it is, like at Dagster Labs, we frequently have our software engineers from the product side contribute to our data pipelines. However, we don't want them to care about what build system we're using, which extra dependency is installed, what DBT is, what the order of operations to get things going is. We just want them to go ahead and contribute and write what they need to. So we have scripts like our makefile to run everything for them. All they have to do is clone the repo, run make dev install, and then make dev. And additionally, we want our engineers to only need to configure or set up services that they need to be using. So to do this, we resolve most of our environment variables and checks at the runtime of a relevant pipeline or the asset that's trying to be built. So for example, You don't need to configure Snowflake, and you don't need Snowflake access if all you're doing is just inserting something into an S3 bucket. So yes, make it easy to run and contribute. Then, as data engineers, we're conscious of where we're going to be running our data pipelines. We don't want to be pushing changes directly into production, and we don't want to be working with all historical data all the time while in development. So a best practice that we like to advocate for is having your pipelines be aware of where they're running, such as in production, CI, or in local development. And by being aware, you can optimize for how they're being run. So for example, like when you're in local development, you can isolate to the data of one individual customer or for a short window of time. And using less data means like things will run faster and you can iterate more frequently with your changes. And staging or CI environments might use a clone of your production databases or some mocked data for your unit tests. And then only in your production environment, in your production setting, are you actually using the full scale of your production databases. In our case, we have a suite of utilities that we use across our pipelines to help us figure out what environment we're running in, where we should be reading or writing data from, and what services we're using. So yes, optimize your workflows per environment. It'll save you a bunch of time and money. Absolutely worth it. And then this last lesson is, if you want to scale, eventually you'll reach the point where you have to think of your data in partitions. So in data engineering, how you partition your data is incredibly important because it can be the difference of your pipelines taking 30 hours to run or 30 minutes. And to clarify what partitions are a way to model incremental data. So that rather than working with the entirety of your data, you're only working with a slice of it. And these slices can be defined by any shared dimension or feature for the records, such as the week or a city. And because you're only working with a fraction of your data, your pipelines will require a fraction of the compute, fraction of the costs, and a fraction of the time that they would otherwise. So to begin partitioning your data, you should ask yourself, well, do we have any tables that are frequently ingested, and are they consistently ingested? Because timestamps are a very common thing to partition by, and you can decide the granularity of your partition, such as week, day, or month, based on the volume and frequency the data comes in at. And if you're ingesting data from an application database, you might want to talk to your software engineers and look at what indexes are on those tables, as they can help you inform on how they're being read or written. And the example that I'll talk about here, that is on the slide, is something that you can apply directly to your organization today if you use AWS. Because AWS provides an option to continuously export every cost and line item from your AWS account into an S3 bucket. It creates a new directory for every month, and it has a varying number of Parquet files inside of it. So to help inform our finance team on our infrastructure costs, we ingest these files into Snowflake as one table for analysis. Now, originally when this was written, it was working with data from the beginning of that year up until now. And this worked fine for a short period of time. However, we eventually had the need to turn on all historical data with it. And this increased the data volume so much that our Snowflake warehouses were timing out trying to ingest it regardless of what size of warehouse we were trying to throw at it. And so intuitively to us, we wanted to partition it. And we observed and saw that, okay, yeah, actually the folder structure of this indicates that we are going to get, like there is a general structure of monthly level Parquet files and reports. So we just decided to partition this asset and this pipeline by month. And now we are only ingesting and working with an individual month of data at a time, which means that we can drop back down to a smaller Snowflake warehouse. And now we can routinely run this on a monthly basis and get what we need. And get full observability over how much we're spending on AWS. So yes, save time by partitioning your data. And as a recap, these are the 4 lessons that we just learned about. And there are literally dozens of other lessons that you can learn from Dagster Open Platform if you look at the repo and just look through the code. Then, how else can you learn? Let's talk about a few other resources available to you. Here are 4 other organizations that we've found that also open sourced their data platforms. You might be familiar with maybe MIT Open Learning, as the one who leads it is Tobias Macy of the Data Engineering Podcast. The IBIS project open sourced their analytics as a Streamlit app powered by Dagster. And GitLab and Mattermost have been open sourcing their data pipelines for years now. And I believe their PRs are public, so you can even look at the discourse and the trade-offs and discussions going on there if you're interested. And if you want to hear about some more intermediate level Python work, we have a decent amount of intermediate level Python guides available to you to help you navigate best practices around virtual environments, design patterns like write, audit, publish, or factories again, or just what is the difference between a wheel and egg and why should I care about it? And if data engineers are just constantly throwing more and more jargon at you, we also have a decently sized glossary and dictionary of data engineering terms you can look at. A lot of these, it's probably 100, 150-ish or so words. A lot of them come with relevant code snippets and examples that you can look at and reference. And if you're interested in learning more about Dagster, though, there's Dagster University. This is our in-depth 6 to 8 hour long course on data engineering through Dagster that teaches you the philosophies and mental models of approaching writing asset-based data pipelines. And we recently also released a course on using DBT and Dagster together by leveraging the strengths of both tools and doing more with both of them combined, such as being able to partition your DBT models. And if you are interested in learning more about design patterns, Refactoring Guru is probably the bleeding edge and the place to look at on the internet if you are interested in learning more about design patterns. It has a great encyclopedia of a variety of them, in addition to the trade-offs, pros and cons, and use cases of how you'd want to approach them. All right, so my last bit is about how I'd like to express a wish of mine. My wish is that you consider sharing some code yourself. As we talked about early on, being a data engineer is a really lonely role. And I'll say that the most rewarding part of all this effort is being able to share it all with you today. Because behind every screenshot and line of code is hours of discussing design documents and debugging. And if there's even one person that applies anything that they see here or in the repository, and because of that, enjoys their jobs just a little bit more, or they save their future selves just a few more hours, then I've done exactly what I wanted to do. And if that feeling resonates with you, I'd like to suggest that you look internally and see what you can share for yourself. The data engineering community is only as strong as the people who make it, such as yourself. So if you're interested in showing off your own work, here are some tips to navigate that. Here are 5 steps I recommend you go through, and we'll talk through each of them. The first step is to acknowledge that you'll need organizational support to do this. Talk to your relevant managers and leaders and communicate why you want to do this, the benefit of it, and build that trust that this open sourcing process is worthwhile. I'm not here to dictate why you might want to open source your data pipelines. I mean, it's a pretty cool thing to do, admittedly, but you may want to share your work out of pure goodwill, or use that as a way to establish your company as a leader in doing analytics well. And it's important to state that and communicate that to your leaders clearly, and then also communicate the benefit of this to them. For example, once mentioned, it's a great way to build a good reputation, and it helps improve recruiting efforts if you're trying to grow your data engineering team long term. Then you also have to prove that you can be trusted. Be prepared to listen to what they ask for, view things from their perspective, and assure them that they will be listened to. Which segues to my next point, which is on navigating the priorities and needs of this project. So talk to your leadership and document these priorities and make plans for how you're going to prioritize them. Establishing and documenting your priorities early on is essential because these are going to act as your North Stars on what processes and details you'll have to bring into this on day one. And if these steps sound familiar, it's because they are. This is the same requirements gathering phase that you'd use for any project with stakeholders, such as building metrics or creating trusted analytics in your organization. In our case, after working with leadership, these are the 3 priorities that we decided to use as our North Stars. Now, our number 1 priority was to always be compliant. We should never expose any internal data, any customer data, or sensitive business logic. We follow all of the same security and compliance requirements as every other SaaS organization, and we refuse to test the limits on that. And the second priority is to never sacrifice developer productivity. These are our production data pipelines first, and an educational resource for the community second. We don't want to make it so that PRs took longer or took longer to merge because a data engineer would have to jump through additional hoops, or even worse, intentionally limiting the work they do because they know it'll be open sourced. So in order to continue providing this resource at the bar for quality that we wanted to, we knew that any steps or processes we had in place would not impede on the development process. And Dagster Labs has an amazing and very strong engineering culture, and we didn't want to deviate from that. We still wanted to centralize on the same CI/CD systems, the same linters, rules, as the software engineers and the product side of the company. So we had to make sure that we were still in coordination with them and took advantage of the best practices and resources available across the entire organization. Now, the last priority is a fun one. Just like anyone else, we don't want to intentionally write poor quality code. But it's inspiring to know that anyone can look at our code and learn something new. In a sense, it's like having your own personal intern that you just want to help foster their growth for, kind of like a little Tamagotchi or a Neopet. So rather than making stricter reviews or more hoops to jump through just for the sake of being able to open source, we instead want to use the knowledge that we're open sourcing as a forcing function to help us write better quality code, knowing that anyone in the world can look at us and call us out on it. So the next step is your standard project planning step. Understand what you're signing up for and the steps for it. So for us, it meant planning to implement some automation and find a way for us to surface our code to the public and do it securely. We also wanted to communicate that that anyone committing to this project, that their code might be open sourced. An additional requirement that we had was that we wanted to make sure that this decision was a two-way door. We wanted to implement it in a way that if we ever felt that we were sacrificing any of our priorities, we would easily be able to stop publishing our data pipelines and reel them back into our private repository. So here's how we did it when we built these processes and safeguards. All pull requests and review happens within an internal repository. This is part of the compliance and productivity portion of it. This way, we're able to vet and confirm that we're not accidentally committing something that we shouldn't, like an API key, before it ever goes out into open source. It's much easier to git bisect one repo than it is to do it to two, so figured that would be the easy way to do it. It also means that we can talk about specifics, such as the implications and details of certain customers, freely without accidentally releasing their name to the world. And then after that, merge pull requests push code changes to a public repository. We have a GitHub action that does this so that every time someone updates the relevant files and merges it into the master branch, it kicks off a GitHub action that copies the files and deploys it out to a separate repository. And that any things we want to keep private are defined in like this git ignore-like file. So we have and this part is factored into that push process from that other GitHub action. But we have even more actions and steps to help us stay in line, such as a GitHub action that comments in our PRs if we're modifying any files that are going to be ignored. All right, and then the last step of this all is probably the most important. Make the culture shift across your company. like you are not the only person impacted by this. You've already talked to your leadership at this point, but now it's time to also communicate to everyone else impacted that this is happening. Your team aren't the only ones open sourcing data pipelines. Your entire company is. So you want to get everyone brought into these processes, including your product team software engineers that may contribute from time to time, or sales, or your finance teams. Since we started working on Dagster Open Platform, we've also since hired 2 more data engineers onto our team, and it takes a bit to get them onboarded and trained into contributing to the open source process. So that's why we really spruced up our documentation and are constantly iterating on making it better to help ease people onboarding onto it. And as we've been scaling too, we've added more automation and provisions, such as that GitHub action I just talked about that leaves a comment of saying, hey, these files are or aren't getting ignored when you try merging to master. And probably most importantly, it's to note that like this step never ends. There will always be more to add on. There will always be sharp edges you can hone in on, and more people who want to get involved in the analytics process, and which is a great problem to have. So yes, it is absolutely worth doing this. The reception to DOPE has been great. We have a stronger and more active community of data engineers. It is amazing to be able to work with our data engineers in our community and be able to link to real life contextualized examples for them. It's great to have self-sufficient users who star, hint, hint, and watch this repository to see what changes are coming out and apply those changes themselves in their own pipelines and then share that with other people. And it's still nice, it's still great to also be able to not impede our developer productivity by having engineers on our side contribute to this easily. If anything, it's probably easier for them to contribute now because we invest in our developer experience so much since then. And yeah, absolutely worth it. In summary, here are the 5 steps that I recommend going through, and that's how we did them. And summary of all this, data engineering is a very hard and lonely journey, as I've been saying. Dagster Open Platform is a public project for you to learn software engineering best practices from. And navigating the open source process is like building trusted analytics in which you have to go through requirements gathering. You have to understand what your stakeholders care about, and you have to factor that in to the process that you're doing to open source. And if you're interested, feel free to check out the Dagster Open Platform repository on GitHub. Feel free to give it a star or something. And if you liked what Dagster was in the brief second I mentioned it, feel free to try it out. It's a Python-based framework for orchestrating data pipelines. Feel free to visit dagster.io for it, or just pip install Dagster. And yeah, that's everything.